Welcome back to the 16th video about my electronic steering wheel / Rudder Jog IP68 project. In the previous video we finished the main body. It's but ugly at some places, but it will hopefully be good enough. Card here, link in the description. Quite a while ago, we already finished the wheel hub. Also, card here, link in the description. And so it's time now to make a shaft to actually connect the two parts. Enjoy! Here's a detailed drawing of the shaft, and I will concentrate on the stuff that has to be done in the lathe, because in this video I will start with the lathe work. So we have obviously here at the end 11 millimeter M6 thread sticking out, so we have to turn on that shoulder down here initially to, well, 5.88 millimeters, and then we have to cut the threads. And that little stub will stick out in the front of the wheel and be secured with a nut. Then we have this very long diameter of 16 millimeters, and that will partly disappear inside the wheel hub and inside the main body. Yeah, that big 16 millimeter hole that made me so many problems, caused me so many problems. Card here, link in the description. And finally we have a second shoulder here at the end with some kind of, however you want to call that, head or boss. And that goes into that large rectangular pocket inside the main body and keeps the shaft from, so you cannot pull out the shaft. Other features we have to do on the lathe, let me think. Yeah, there is another round pocket here at the end. It's not big, 8 millimeter diameter, 2.5 millimeters deep. That will house a magnet for a well, magnetic angle decoder. It's an electronic steering wheel, so we want to measure the angle at which we are. I have some raw aluminum round stock here, which is incidentally 24 millimeters, because the exact outside diameter here and how that looks of the boss at the end, I don't care. We can take the raw finish of that. Yeah, I think that's drawn or cast, I don't know, or pressed aluminum round stock. And we have here at the end 16 millimeters, and that should be enough if I leave a little bit more space here for cleaning up that end to grab that in the lathe. So yeah, let's cut off something like 125 millimeters of the stock material and put it into the lathe and start making chips. My round stock is in the lathe, and we're dialed into about, plus minus 700s, maybe 600s. That's good enough, especially, I think I mentioned that before, a round stock is not really round. Let's clean up the face now. With the face cleaned up, we can now drill with the center drill a hole for our live center. Now I made a mark here at 107 millimeters here from the end. This part should be 105 millimeters in the end, so we have an error margin of 2 millimeters, which we can play with. Also, the boss here, that's what will be left, the thickest end, the thickest part, that should be 16 millimeters, and I set that to 16 millimeters, and you see we not that way. We also have an error margin of 2 millimeters on that side after we turned everything around. So that should be okay. And now we just have to turn that down to our first diameter of approximately 16 millimeters with a nice shoulder at that side. I was going very slowly and carefully, only advancing half a tenth or a tenth until I got a nice surface here and just scratching here at the end. And as you can see, we've reached our mark perfectly. So I put in now my Proxon workaround. Trademark mechanical stop here. That's more like an optical marker that I'm actually reaching the end. We talked about that in previous videos. Okay, and if that is, sorry, just touching here on my cross slide, I go back to the other end and put that ring here to 0. So together with the clamp and the ring being on 0, I can reliably position my tool at that distance again and again and again. And now the real work begins, turning that stuff here down to 60 millimeter is the goal, let's say 16.5 millimeter. And then we take a measurement. That was a glorious mess, and we won't take off that much material in the next operations. That's really the absolute maximum that we had to take off. So I measured a little bit off camera and I came to 16.51 to 16.54, 55. Can you read that? If I go actually upwards here, it's down to 5.4, but I can show you. And our goal is somewhere between 15.9 and 16. The problem being that all my holes I drilled, my nominal 60 millimeter holes, have slightly different diameters. So in the next step, I will advance, let's say 0.25, and then we should be at 16, and then we go from there. And now we are at 16.01. Okay. Again, I cannot really show that. You maybe here at the front. Can you read that? But if I put it that, it's a little bit more at 16.08. You have to believe me. If I'm doing it this way, we are at 16.02. Okay, do I try to advance a 500th here, or do I simply take on some sandpaper? I opt for sandpaper because really at most, we have to take off 5/100ths. So half a tenth. And yeah, if I take up too much, I can throw it away. So sandpaper it is. But before we do that, yeah, with the settings and everything locked, I will go back here, advance 0.2 millimeters further, and then go out just to clean up the shoulder nicely. You might have noticed after I pressed in 0.2 millimeters, I first went inward a tenth of a millimeter just to make here the tiniest of a relief cut so that the shoulder and yeah, our shaft are not somehow here interacting with some radius here inside the main body. And then I went out, and we will see that later on. The shoulder is really nice, and now all I have to do is round off here a little bit with the file. You might also have noticed as I went over the whole thing again inwards here, I took off a little bit more material. That was unexpected, but we're now at, oops, sorry, 15.97. Yeah, now, yeah, you can almost read it. 15.99. It's 97 if I measure it correctly here. 15.94. So definitely time to check the fit. But before we can do that, I should probably put a little face here too. Yeah, that's better. So from that side, my main body is almost fitting, almost. But from that side, no chance. There are a few hundreds we have to go down here. So let me break out the sandpaper. I don't know if you were able to see it, but that's now a really tight fit. I'm not putting it all the way down. Yes, I am. I can't really test the last 10, 12 millimeters or so because the lathe is in the way, and I'm certainly not taking that out now of the truck. It's supposed to be a tight fit, okay? I need a little bit of friction here because otherwise the wheel will be just freewheeling, and you can't have that with an electronic wheel because every movement of the wheel will result in a control signal to, well, in that case, probably a rudder or something. We will see. Perfect. Next step would be to cut the next shoulder in here, and the distance according to the drawing is 94 millimeters, and I set my caliper to 94.2 because I will first approach, and remember on the last pass I will advance 0.2 millimeters more and then move out. And yeah, I hope that's okay. The measurement is not completely critical. If we are off a tenth or two, yeah, it won't break anything. And it's exactly the same game. I will go up to my line of the first cut and put a stop on there and set my wheel, it's down here, to 0, so I can always repeat at least the length I go down here. We are at, can you read that? Probably yes, 6.26, 6.24. And we have to go down nominally to 5.88. So in diameter, that's 0.36. I have to advance here on the cross side, slide 0.18. Yeah, if we end up at 5.9, it doesn't matter. It's aluminum. The die for cutting the thread can take it. So I will advance, yeah, eyeballing it 0.175. Lengthwise, we are at, and no, I can't really show you that. Oh, maybe I can. But it looks like we're 93.96. Okay. So I won't clean up that shoulder. It's also not really important. That shoulder will interact with nothing. Yeah, there will be an air gap. So that's okay. And yeah, I should have that 0.175 millimeters still space here. Just so. If not, you will definitely hear it. And I totally forgot to film that last path. But yeah, sorry. I was nervous. And we are now at 5.92. That's close enough to 5.88. I mean 400ths, no problem. We can round off that shoulder with a file. Nice. So lengthwise, we are here at 13.55. 13.57. Let's say 13.55. We want to go down to 11 here for that little stub that will be threaded. So let's say 13.5, 11, we have to take 2.5 millimeters off. And then we measure again. I took very shallow cuts, only 0.1 millimeter on each round because of the enormous stick out. I don't want to put too much force here at the long end. And I stopped at 2.4 millimeters, so we can take another measurement. And we are officially at 11.02. Yeah, good thing I stopped, huh? 10.98. Okay, that's good enough. Let's put a nice chamfer on here so the die for the M6 thread can go on easily. Yep, that should be enough. And now we are cutting the thread. So just a wee bit of cutting oil. I have the die in the right way around and I can rest it here and I can use the tailstock to align it, and then I have to turn here. I think it's counterclockwise. This is almost going too easy. Oh, my arm is in the way. I'm sorry about that. have to get the chips out here of the gap. Clearing the chips out of the gap once more, as far as that's possible. Up a little bit, cleaning out chips. And we're there. One very nice M6 thread. But it's only a real M6 thread if I'm able to put on a M6 nut. Yeah, works like a charm. I've turned the part around now, and I'm really lucky that the 16mm shaft here is really almost all fitting in here. Yeah, somewhere within the gearing. It's not officially a 16mm through hole here. It's smaller, but yeah, stick out is not too bad. And I didn't bother with dialing it in because we really need to shorten that thing here. We are currently at where's my caliper? Yeah, about 17.8 millimeters, but I think I will first clean up the face and then we take an exact measurement. Anyway, we have to go down to 60 millimeters. So this has cleaned up nicely and we are at 1777 was the lowest I measured, 1778, and here, yeah, let's say 17.8. I have to go down 1.8 millimeters. And I will go down 1.7 and then we measure again. Okay, I was a little bit conservative and only took 1.5 millimeters off. And we are at, yeah, maybe that was a good idea, 16.18, 16.2, 16.24, yeah, 16.18. Okay, I guess I take a last cut 0.15 millimeters. And we are hopefully at 16.0 something. 16, you can't read that. I'm sorry. 16.04, I saw something below that. 16.0, come on. 03, 16.03, that's good. Look here, 16.02, 03, 02. Okay, I take that and I will clean up that edge here now. Yeah, that's better. Onwards to our last operation on the lathe. Before we come to the very last operation, I have forgotten to clean up that edge here. Okay, that's better. Now, the very last operation is to mill a 2.5 millimeter deep hole here at the end. And yeah, 8 millimeter diameter, so I have an 8 millimeter end mill in here. And I'm just putting my tailstock into position and lock it. And then I advance until I'm touching and set my scale here to 0. And then we mill. Now we have a tiny little problem here. There's something left, and that's because that end mill, yeah, has a hole in the middle. So we take a smaller two-fluted 6mm end mill that doesn't have a hole in the middle and try to, yeah, remove that leftover piece there. So that's better but not perfect. The magnet that should go in here is not sitting flush. There's only a little bit missing. Let me think about that. The only thing I could come up with at short notice is to use a drill to make a little dent in the middle to remove that mount. Hopefully that will work. Almost. Okay, it's still not fitting. I'm trying to give you here a view down the barrel, and this is now really where I made a little divot, so this is going inward here really with the drill, but it's still not fitting because we have, can you see that? It seems to have, we have here a little step, and that step is going all around. And let me measure the depth of that step here. That step here is definitely less than 2.5 millimeters. Okay, back to the 8mm end mill. Okay, the magnet is now absolutely flush in here. Very well. Well, I put some drops of super glues when I put everything together on that thing, but I wanted to avoid that. Oh, there are metal parts on this lathe. Shoot. But yeah, you can see it's absolutely flush. Yeah, to the 100th of a millimeter. Perfect. I mean, the hole inside, it doesn't look pretty right now. If you can learn one thing from my experience or my mistakes, if you take, can I zoom in a little bit? A 4-fluted end mill with a hole in the middle and you want to make such a pocket, first use a drill with a slightly smaller diameter so your material will not interfere with the hole here, because there's no cutting here in the center of that end mill. Yeah. Anyway, that's it for today. In the next video we will take that thing out of the lathe and we will put it in the ominously standing in the background mill, and create 2 more features on that thing. Slot for a keyway, so a keyway for a key, and almost through hole here in the boss at the end for a stop bolt. Till then, bye.